right. I've put the stream live. The live
We're
stream
live.
is live.
It's happening.
Now we just need to wait, as always, for some kind of observation.
Anyone.
Yeah, to tell us
Anyone.
that we
Is
exist.
anyone out there?
30 seconds passed. No way. Well, maybe. But I thought I flipped the switch.
Sorry.
Flipped the switch precisely. Maybe Desway has some kind of...
You're in a different time zone.
The 30-second time zone?
Yeah.
Yeah, that's like just a little a ways from us. No Blackboard background. All right.
I know. Man, everyone's
explain.
freaking out.
I know. It's really unnerving. Why do you not have black?
I know. It's just new digs. Just get over it. I'll figure out the Blackboard wall soon. Don't worry about it.
Yeah. All right. Okay. Well, apparently people are confirming our existence. Hey, everyone.
Hey.
It's time for our Monday live QA, where you get a chance to, I don't know, ask a spaceman, space radio. Yeah. This is like, at this point, this is just like our bread and butter, isn't it? So.
Oh yeah, just Q&A, just showing up and people giving me Q's, me giving them nays.
Yeah, it's nice when, like, on the one hand, you have to prepare everything all the time, but on the other hand, once you've prepared all the things all the time, then you don't have to prepare at all. Yeah,
or you just make it up as you go along. It's like improv comedy.
I don't think science works that way.
Oh, really?
No.
Okay. That's not how knowledge and facts work.
No, I don't think
it's just improv comedy.
Yeah, that you're just making it all up as you go along. Although I'm sure people would get into that. So before we get into people's questions, I've realized now that I want to like greedily steal a little bit of your time for my own dread purposes, and then we'll move into everyone else's questions. But maybe this will give me a place to start. So you posted an article like, if anyone has no idea, this is Dr. Paul Sutter. Who are you again?
I'm Dr. Paul Sutter. I'm an astrophysicist at The Ohio State University, and I do a bunch of things. I'm the host of the Ask a Spaceman podcast, space radio on radio. I'm on the latest season of How the Universe Works on TV. My latest book, How the Universe, or Your Place in the Universe, is out in bookstores nationwide now. And I do a bunch of cool art and science collaborations. I'm currently working on a project with Siren Monitor Dance in New York called TikTok on the nature of time.
And of course, obviously, we work together every week, so people are probably very familiar.
With our
conversations on the Weekly Space Hangout. So you posted a article today-ish, reasonably
sure,
within the last couple of days, about how to deal with people who are providing a barrage of nonsensical arguments. So can you sort of set this up and give us the way out?
Yeah, so there's this common situation which you see in debates between scientists and non-scientists, or believers and skeptics, or just any time a scientist has to go up and debate someone who is not coming at it from a scientific perspective. A very underhanded and cheap but very common debating tactic is to just flood like ridiculous statement number 1, ridiculous statement number 2, ridiculous statement number 3 and 4 and 5 and 6, and just keep going boom, 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 boom. And your immediate reaction as the other person in the debate is to be like, okay, in order for the audience to see my point of view, I have to take down every single one of these arguments and show how they're unfounded or untrue or misrepresenting everything. And that takes a lot of time. So you start at the first and you just start going, okay, you need to spend a couple minutes here, and then you go on to the second one, and then you go on to, and then you're out of time, and you've left a whole bunch of arguments just floating in the wind unanswered. So and this makes you look bad. It makes science look bad. It's like, hey, there are a lot of problems with that scientific viewpoint, and the scientist wasn't able to defend that viewpoint. So my strategy, my answer to that is, you're never going to get through all the responses because there simply isn't enough time in the heat death of the universe to respond to every single point at the detail it needs to really take it down. So instead, just pick one. Only look at one argument, one statement. Maybe it's the most egregious one. Maybe it's the hardest one to take down. Maybe it's the easiest one to take down. Maybe it's the most emotional. Maybe it's the most personally connected to your audience or what you think your audience wants. Maybe it's the most practical. Like pick some criteria that you think will resonate with the audience and address that in complete and total detail. Use this as an opportunity to tell your own story. Use this as an opportunity to express your own viewpoint, to answer it, address it, and then steer the conversation in a new direction. There will still be unanswered questions and arguments that haven't been responded to, but that's going to be true no matter what. So pick the one that you think the audience will most care about.
But isn't that if the person you're arguing is arguing in some form of good faith? Because that's the other, often that barrage, that flooding the end zone. I don't know if that's the right sports ball reference.
Sure.
But is this idea of like, your goal is not to come to an agreement. Your goal is not to understand the other person's point of view. Your goal is to win. And you mentioned that as like the worst possible argument to get yourself caught into is with someone who is only interested in winning, not interested in anything else.
Right.
That is, and I think with that, your only real objective goes back to your previous one, which is to like not play, to not engage.
So if you're in an honest debate, then honest debates have structures and rules and modes and politeness where you won't even have to face this kind of stuff, where you're exploring a topic from different angles and looking for nuances and subtleties and learning as much as you are speaking. But if you're in an inhonest debate and your opponent is not coming from an honest place and really just trying to demolish and convince and trying to win the audience over, then you got to play a different game.
Yeah. All right. Well, let's get into a few cool questions have come our way. And I just want to warn everybody in advance that I'm going to use my sizable knowledge as a science journalist to really take the zingers. So I'm going to use my judgment and really try to hit Paul with the hard questions. So
bring it.
Not the impossible ones, the hard ones. So let's get cracking here.
The impossible ones we're just getting past.
And if I think that people have pulled their punches and they've asked sort of a not a hard enough question,
softies.
Yeah, I reserve the right to take your question and make it harder.
You'll punch it up. You'll punch it up.
So here's a good one. HQ Cart asks, what physical property of an object would there need to be in order to crack the light speed limit? So so right now we assume that we can't travel faster than the speed of light. What would it take?
Don't assume that.
Right now, what did I say? Right now, we don't think that it's possible to travel faster than the speed of light. Did I say something?
You said we assume you can't travel faster than the speed of light, and I got you.
Right, of course.
Like,
yeah, right. Obviously, we just don't know enough. So what would it take for us to be able to travel faster than the speed of light?
So if you want something to travel faster than the speed of light, it has to have zero mass. If you have any bit of mass at all, even a tiny bit, you will not crack the speed of light barrier no matter how hard you work. And here's the problem. Here's the issue. Equals MC squared, right?
Sure.
Yeah, okay, sure, whatever. Energy equals mass times the speed of light squared. Energy equals mass. Energy is mass. Mass is energy. They're the exact same thing. Two sides of the same coin. If you have more energy, you have more mass. A hot cup of coffee literally weighs more than a cold cup of coffee because it has more energy.
Right.
As you start traveling faster, you get a lot of kinetic energy because you're moving. That kinetic energy is mass. You are literally heavier the faster you move than if you were perfectly still. And as you get faster and faster, you get more and more heavier, which means you get harder and harder to push. And as you get closer to the speed of light, you have more and more energy, which means you get more and more massive. And eventually you get to be, if you want to cross the speed of light, if you want to go over that bridge, if you want to go from 99.9999999% the speed of light to 100% the speed of light, you're going to have an infinite amount of mass, which means you need an infinite amount of energy to get you there. And that's not a thing. So if you have any tiny bit of mass, you are stuck to sublight speeds. Done.
But so, I mean, wipe out all the mass, wipe out all the energy, make it zero. I've heard people say that if you had negative mass, that would make your life even better.
Okay, so if you have negative mass, if you were to weigh like negative 10 pounds or have a mass of negative 47 kilograms, then about half the known laws of physics are out the window,
sure,
including conservation of momentum, let alone special relativity. So, yeah, we don't think negative mass is a thing for many reasons, and that's one of them.
No warp drive, sorry. Mr. Tom Harbin asks, I'm writing a dissertation on creating scientific visualizations and how to help build public interest and ultimately trust. How can we help foster this at the academic level?
Yeah, so academics are the hardest audience to convince to do anything because a typical professor at a typical university has one job, which is get grants. In order to get grants, they also have to write papers, so that's job number 2. And then there's a long gap, and then somewhere down here is teaching duties. Yeah. And then below that is service to the department, like serving on committees, and then a long gap after that. And you have things like hobbies and family life. And then below that is other, which includes outreach and engagement. Most universities simply don't incentivize outreach and engagement. There's no reward for a typical professor to do outreach. So instead, there's professors that just like to do outreach as a hobby, as a fun thing, as that 1 hour a week that they can spend on anything other than work, sleep, and eat.
Right.
And it's a matter of finding those needles in the haystack, of looking through universities, looking at press releases, seeing who's active, see who's already interested, and connecting with them, having conversations with them, and being very, very, very patient because they might be very excited about the idea, but they also have no time.
But is that what you have become? Like, what for a lot of people, they go through the work and they're doing the research and they don't have the time. You have emphasized more on the public outreach.
Yeah.
And that's got to take away from your time of actually doing the research.
Yeah. And so that was an intentional choice over the past few years to wind down a bunch of my research threads to open up the time to do more outreach and communication because I felt very passionately about it. It was very, very fun. I felt a calling to it. And so that was an intentional choice. And I've been very lucky at OSU, at the Ohio State University, that they have supported me and helped guide me through this process. And they've got my back through the whole thing. So I am more of an exception than a rule when it comes to universities.
But when you think about the amount of money that the university will spend on, say, public relations, I mean, they have a team, they'll have an outside public relations agency. If they have even bigger budget, they'll be doing television work, they'll be doing radio work, they'll be doing shows and things like that. So they clearly know from an institutional level that their funding is partly provided by the public celebrating the discoveries that they're making. And yet I think that within the scientific community, for many of them, like a lot of scientists, and maybe just because scientists are so busier these days, but it's like they feel torn in all these different directions, where on the one hand they feel the pressure to publish, pressure to bring in grants, etc., and then at the same time they feel I think the pressure to communicate their work to the public.
Yeah.
If you could play God and sort of change the mix,
don't tempt
for
me.
People, yeah. Where would you come down? Where would you, sort of land on that?
I think overall the academic workload, it needs to be reduced. In general, there is a very, very unhealthy work-life balances in the academic world, especially for young researchers. And
unlike the healthy work-life balance in the science communicators world.
Yeah, but I choose this voluntarily. Sure. Yeah, good point.
I mean, just like the journalists, which you are now, by the way, are overwhelmed too. Okay. So I think, right, there's no way out of this in any way, shape, or form.
I don't know. I took a 3-hour nap today.
Oh, congratulations.
That's pretty. No, I didn't. I wish I did. Right. I thought about taking a nap for 3 hours. Nice. Does that count?
Yeah. But I think at least to not have the stigma to be communicating with the public, yes. Like back in the day, right? Sagan was...
Yeah, he'd get tons of heat.
Yeah, he got tons of heat. He was punished for being out there in the public, right? But at the same time, now I think there's a lot of celebrities that we could name, many of them who are both scientists and fairly skillful communicators. Mm-hmm. And it would be nice if there was better support, because I think it's being able to provide the people who have even a mild interest in it, in the support to help them reach their audience and communicate with a lot of the technical details that they don't necessarily need to know, right?
Yeah. I think you're right. There's tons of infrastructure now, especially with social media. It's so easy for scientists and researchers to just connect directly to the public. But there's still that stigma. There is still that institutional bias, and there's just no incentives. Like if a young faculty member wants to get into outreach and communication, at best, it's neutral in terms of their career advancement and gaining tenure. At best, it's neutral.
Yeah.
Usually it's a negative, because they're like, why aren't you spending that time getting grants or writing papers? So changing the incentive structure at an institutional level or department level, where it's like, the expectation is that you do a little bit of outreach.
Yes. That
is a part of your job. And they'll do it because they want that job.
Desway asks if I'm planning on doing open space with Scott Manley. Yes. Date to be announced, but yes. Arjone asks...
Because he thought I was Scott Manley.
I know.
Wrong accent.
All a bunch of bald guys, Phil Plate, Scott Manley, we'll get all of us together. Arjone asks, if we get a way to tell if a planet has life or not, is it okay to seed planets with life? What do you think? So...
Like, is it okay? Like, cool? Or
fun? Like, is it morally ambiguous for us to seed other worlds with life? If we know there's life there, microbes, is it okay for us to populate it with Earth creatures? We'll start there, and then the counter. If we know that it's dead, is it okay?
I would say, and this is my own personal opinion, and no one actually asked me for real, if extrasolar planets, it's never going to matter. We're never going to send anything interesting there for a very, very, very long time. So we can it's a moot point. We'll get to observe life, but we won't get to visit it or talk to it. When it comes to our own solar system, I think if there are signs of life, dug up on Mars or under the oceans of Europa or Enceladus or wherever, that life, carved a niche, that is a huge discovery. Like, that is monumentally changing our view of humanity and our role in the cosmos and our place in the cosmos. And that deserves a lot of careful attention. It deserves a lot of careful scientific attention before we can imagine polluting it and bringing in our own DNA and start mucking around with stuff. And I would say if the planet is truly dead, well, it's ours for the taking, right?
Right. It's just a rock. Like you don't...
It's just a rock.
Yeah.
It's just a rock.
The size of the rock, now doesn't really matter.
It's a large rock.
But I think that's a great point, right? Which is like if we do find life there, then it's really the race is on for us to make it impossible to derive any further scientific inquiry about the nature of the life there.
Yeah.
Right? And if
huge questions that will need answered before it'll take a long time too.
And so it's just going to be a race between scientists and Muskian colonists and developers. Yeah, who are
they're going to put a railroad in.
Yeah, Mars lawns and killing off the local Mars fungus. So
the Trans-Martian Railroad.
Right. There you go. All right. So TWGP says, if space debris is so dangerous, how do satellites and the International Space Station prevent damage?
Oh, yeah. So space debris is super dangerous, and we need to keep a very, very close eye on it. Thankfully, space is also gigantic. Like, there's just so much room up there. So it's through a combination of knowing where all the big stuff is, keeping track of it, making sure orbits don't intersect with the known stuff, and then, that's pretty much it. It's just there's enough volume up there that chances are you're not going to hit anything major. I mean, there's always a small chance, but that's life.
Yeah, you can see pictures of the debris that has hit the International Space Station. There's little pockmarks on.
Oh yeah, didn't they get one in like a window once, and you can see it?
They had the space shuttle. You could see the
space shuttle.
Yeah, all of the little pieces of debris that hit the front window of the space shuttle. So they are getting hit by little chunks of debris all the time. They're just not getting. They just haven't gotten hit by large chunks of debris yet. Yet, yeah, exactly. So there's a couple of questions here which I don't think you know that much about, so I don't want to necessarily put you on the spot. They're hard questions. One is sort of this idea of quantized inertia. I don't know if you looked into this at all.
Inertia is not quantized.
So there you go. That's your feeling. And then the other one is this recent Ashtkar Olmedo Singh paper that uses quantum loop gravity to demonstrate black holes turn into white holes. No.
Sure. Whatevs.
Yeah. More evidence. Like, deliver the evidence.
And guess what? Or just like, we don't understand loop quantum gravity, so it's an interesting, like, loop quantum gravity, like that paper, it's a legit paper. It's exploring this corner of a very super hypothetical field of physics. Doesn't really say anything about the way nature works.
Right. I mean, the search for the way to integrate gravity and, all of the other fundamental forces, if someone makes that's on par with that discovery of life on Mars. It's the same scale.
Yeah, that's a big deal.
It's a big deal. Yeah. And so you got to be sure.
Super sure. And just one, it's not going to be one paper that's going to change the world.
What do you think then about, say, how well these kinds of ideas play out in media? That this, as opposed to, additional emissions in the H2 spectrum, blah, 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 at Z equals 426.
Yeah.
Right? As opposed to black holes can turn into white holes.
Whatever that means.
So do you think, are we doing scientific discovery a disservice by we as journalists? And again, I described you as a journalist as well now.
Yep. So self-blame here.
Yeah, we're focusing on this kind of stuff as opposed to the drier bread and butter of observing large clouds of hydrogen gas at the very limits of our observations.
Yeah. I mean, this is such a tough call because if you look at the list of latest papers that were published yesterday or the day before, 90% of them are super boring. They're just really dry, really academic. They're on some method or some technique or a statistical analysis or an observation. It's just like, that's not really going to grab you. And I don't blame journalists for not latching on to those papers, because at the end of the day, they're doing their job, which is to sell ads. And so they need people staring at these things, and no one's going to read a super boring article about a super boring paper. So I don't blame them for going after the juicy stuff, the keywords, the fun phrases, but it's in the presentation of the actual journal articles. Because, this quantum gravity, black hole to white hole, that's a legitimate paper published in a legitimate journal. It's a highly hypothetical, mathematical approach to a look at some interesting questions. And if it's presented like that, like, oh, this is pencil and paper by a few people, exploring some odd corner of a theoretical construct that we don't fully understand. If it's presented like that, of actually representing what the contents of the journal article and paper is, and in context of everything else we know about the universe, then it's fine, because it's legit science and this is how science is done. But if it's presenting it as, hey, guess what, everyone, black holes can turn into white holes, well, that's not representing the contents in the paper or if it's in with everything else we know about the universe.
And it's possible that there are some science publicizers out there who have made a name for them for, I guess, being willing to talk about this sci-fi Christmas, or, and refusing to ruin sci-fi Christmas. And it's funny, I think, I'm going to pick on one person directly, which is, but I think he can handle it, which is Ethan Siegel. On the one hand, I think does a really great job of bringing the skeptical point of view and bringing a very even-handed approach and doing a great job of communicating the deep underlying science. And he pulls no punches. And I've got a wonderful book all about the technology of Star Trek that he wrote on my shelf,
Yeah.
And I think that that there is this, that at the end of the day, like, part of like why you get into this in the first place has got to be science fiction helped bring you into this in the first place, that the love of what's possible out there and some of these bigger ideas and these more exciting possibilities have got to be propelling this forward. And you live in this dynamic state. I mean, and then I don't know, like, is it this process where, as you learn more about the actual state of the universe, sort of the light falls from your eyes as you learn the cold, hard reality?
Oh, wow. This is actually hard work.
Yeah. Yeah.
And most of it is computer programming.
Yes. By the way, I don't know if you heard the Pan-STARRS data release came out today.
No, I didn't catch it.
1.3 petabytes of information, the entire visible universe from Hawaii, taken with their telescope at incredibly detailed resolution. So,
yikes.
Yeah. So
that's a download. They have a torrent of that.
I don't know. Yeah. Fill a whole bunch of hard drives. That would be cool. So I think it's funny. Like, if I listen back to old episodes of Astronomy Cast, as I'm like nerding out, and Dr. Pamela
and
Gay
listening to yourself.
Yeah, she's bringing me. She's like, well, let's be a little more reasonable. Let's be a little more realistic. Like, here's what's possible. And I'm like, yeah, but warp drives and wormholes and
warp drives,
time travel, And now here I am, 10 years later, and I'm the one like, well, let's just like look at the science and let's consider
hydrogen alpha line.
Yeah. The weak lensing effect on the cosmic microwave background and the presence of dipole anisotropy, for example.
Yeah.
Like, that's pretty big news.
Those are words.
Yeah. So anyway, I feel, I don't know. Do you see this shift happening in your work as a science communicator, that your audience is shifting from sort of buzzword interest to the nuances of the science?
Yeah, I wouldn't call it a shift. I would say my audience self-selects because of the content that I always focus on. Like, my podcast is always about sciencey stuff. I don't dig into the science fiction. Or if I do a topic like wormholes, it's about how wormholes don't exist. Or if it's a topic like time travel, I talk about, well, here's the things we know about time. Here's the physics that we know behind time. And so since that is my bread and butter, like straight up, I'm going to say, I'm an astrophysicist, I'm a scientist, I'm going to provide a scientific perspective on science, and that's it. The kind of people who are interested in just the sci-fi Christmas and imagining future scenarios, regardless of whether they're plausible or not, they're just not going to be interested.
Yeah. Yeah. So you think that they come hoping to hear you tell them that wormholes are possible, and they either leave,
and I crush their dreams,
and they go off to someone who will tell them 10 amazing ways that you can travel faster than light in the universe. And the ones that stick around have self-selected. I don't think so. I think you're educating them. Okay. I think that you are helping to temper their wide-eyed enthusiasm with the wonder of the real science, which when you get to really see the nuances of it is as entertaining as, like, right? There's nothing more.
There's so much beauty. There's so much beauty out there. This is like one of my central mantras is, you don't need to make stuff up.
Yes.
For the universe to be beautiful. It already is. You just have to open your eyes and look around.
And the amazing feats of engineering and observing and theory that have helped us understand some of the things that we already do. Like when you look at the engineering that went into building, say, the LIGO experiment.
Yeah.
Like, there was a lot of people that didn't think that level of precision was even going to be possible. And for them to pull that off is an astonishing capability.
Oh, for sure.
So,
yeah, I mean, just, and so there's the natural curiosity of the universe around us. And then there's also these wonderful, wonderful human interest stories of passionate, dedicated, hardworking, intelligent, creative people working towards a common goal in collaborative environments over the course of years and decades to crack some secret out of Mother Nature. I mean, that's an amazing journey that I think wish more people would recognize.
Yeah. All right. HQ car. Actually, you got a question. Sorry, it was a good question. All right, so Todd Wagner asks, if we discover intelligent life, how do we communicate? What if they don't use language as we know it? What do you think?
Beats me. I mean, we can hardly talk to each other.
Right. You would. I mean, I think we've got a couple of possible routes. The fact that
there's some possible routes. So one possible route is to rely on fundamental physics. Like there are things like a hydrogen atom that you would hope any intelligent species in the universe would recognize the properties of a hydrogen atom, like the hydrogen alpha emission line. All hydrogen across the universe emits light at the exact same frequency. And so you can point to that in some way. And if they can get that, they're like, oh, yeah, that's the hydrogen alpha emission spectrum. Then you can build from there, maybe. I don't know if you'll be at the point of, a dinner conversation.
Right, but you can imagine the time frame back and forth where you're like, did you get that? And they're like, I don't understand. And you're like, hydrogen atom.
That's not. Yeah, yelling doesn't help. Yelling, doesn't make it easier to understand.
Yeah. Yeah, that's it. But I mean, there are ways to send unambiguous signals that it is impossible for the universe to generate naturally, like a radio emission in a certain wavelength, right? So.
Or you start tugging around stars to make a big smiley face.
Yeah.
Or you sign your name with gas clouds or something.
Right.
It's possible to generate unambiguously intelligent signals. Doesn't mean you can decipher those signals or understand their meaning, but you can tell that they are not natural.
Yeah. I really enjoyed. Have you seen Arrival? The movie Arrival?
Arrival is great.
Yeah.
Amy Adams comes unstuck in time.
Yeah, and does a really great job of explaining just like how difficult it would be to actually communicate with someone where you have no constant point of reference and how to move through that. I really enjoyed it. So yeah, why you can't just say, "Why are you here?" and so it's a great movie. There was a question that I liked. All right, GP asks, what is your view on the credibility of the claims that the Large Hadron Collider could create a dangerous black hole which could gobble up the Earth?
Yeah, haven't we ridden this train before?
Yeah, well, now they're going to make the super mega collider.
Oh,
you heard about
well,
this?
Here's
the
the
big
thing,
one?
folks. Here's the thing, folks. Yeah. We have these big, powerful colliders, whatever. Do you think Mother Nature, with supernova and active galactic nuclei and kilonova and merging black holes and the Big Bang itself and merging galaxies, do you think we are overpowering nature?
Right.
Do you think we're at the top end of what nature is capable of? There are particles slamming into our atmosphere, literally 1 trillion times more energetic than provided by the Large Hadron Collider. So if the Large Hadron Collider can produce black holes, then our atmosphere has been generating black holes for 4 billion years.
Right. And we're still here.
Aye.
So come at us. And the theories that predict the black holes will be gone.
Yeah, either they'll evaporate. So if in these high energy collisions, black holes really are produced, then they've been produced for 4 billion years, which means either they just evaporate right away or they slink down to the center of the Earth and they grow so slowly that nothing interesting will happen ever.
And I guess the only advantage that the Large Hadron Collider gives you is it lets you know where these events are going to happen. You can predict them in the future and go,
we have detectors
right here. I want that explosion to happen right in the middle of our detectors, as opposed to I want
when my camera is pointing.
When my camera's pointing, as opposed to I want that explosion to happen somewhere randomly in the vast atmosphere.
But this is an entire field of physics called particle astrophysics, which is relying on nature's awesome power to do high energy particle physics experiments for you.
Yeah. And you would even think like whatever is causing those high energy cosmic rays are like, just imagine the amount of energy and stuff that's going on inside those events. Yeah.
This much energy, a camera frame's width of energy. Like, that's so much.
Adam Sanders asks, will James Webb have been worth it when it gets to orbit, or will cheaper ground-based telescopes have similar capabilities at that point? What is the future of space-based optical telescopes?
Here's my bet.
No.
And no one likes me when I say this.
Okay.
James Webb will never fly. It's too big to launch.
That's a
bring
bold,
it. Yeah, that's my bold claim. That's my bold. I'm just gonna go out there and say it. I hope it goes up. Of course I hope it goes up.
Yeah.
But yeah, I think it's too risky, and NASA's too risk adverse, and they'll never be satisfied that it will actually be able to do the things it needs to do, and they'll never want to take the risk, and they will never launch it.
Yeah. So my plan of encasing the James Webb in a block of glass so that it can never fail.
Yeah.
Is probably the right one.
That's the one. That's the strategy they're taking.
Yeah.
So yeah, even
I think you're wrong.
Galileo's telescope. I think I'm wrong too. Even Galileo's telescope would be better than the James Webb if the James Webb never launches.
You're a monster. At least I just joke about it coming out in the year 3000. but
in the year 3000. Yeah.
All right. Let's see. Stephen Angus is out of here.
Great beef.
Oh, so apologize that I didn't get your question quickly, and it looks like you're gone. So I apologize. Farewell. Next week. All right. Altura619 asks, how common are population 3 stars in the modern universe, and how likely are they to form in the distant future?
All right. So pop 3 stars in the confusing terminology of astronomy. The first generation of stars to appear in the universe are called population 3 stars.
That makes no sense.
But whatever, we'll move past it because we're mature, grown adults.
Yep.
And we suspect, we're pretty dang sure, there are no population 3 stars remaining in our universe today. Or maybe there's like one, but we'll never find it. We've searched and searched and searched and searched in our own galaxy, tons of surveys, nothing. Like, we don't see a single population 3 star. So this tells us that the population 3 stars, the first generation of stars, which had no heavy elements at all, were pure hydrogen, helium, and a little bit of lithium, must have been relatively large. So they all died out quickly. And, within the first generation, within, say, the first 100 million years, all population 3 stars had already been born and had already died. So we got nothing.
All right. Let's see here. All right. Cindy asks, do you think that we live in a 4-dimensional space or a 10-dimensional space?
Ooh, we live in a 4-dimensional space-time, 3 spatial dimensions, 1 of time. You cannot ignore the dimension of time. It is interwoven with the dimensions of space. We do live in a 4-dimensional universe. Now, are there extra spatial dimensions, either big ones or little ones? Are there 10 or 26, maybe 3.5 because, whatever? We don't know. The theories and models and ideas that would predict or rely on a multidimensional universe, kind of shaky ground nowadays. String theory ain't looking so hot anymore. So the answer is maybe, but probably not.
So I guess if string theory is true, then we live in however many dimensions string theory accurately predicted.
Yes.
And if it's not true, then we live in the 3.
Then it's still open.
Then it's still open, but to the best of our ability, we can only detect 3 spatial dimensions and 1 dimension of time.
And in science, we will only make statements of belief when we don't have any evidence to the contrary. But first, you have to make a prediction that can be testable.
Right. And that is all of these. I mean, wormholes and other dimensions and what came before the Big Bang and all of that. Like, predict till you're, to heart's content, but you need to give the experimenters and the observers something they can help you prove.
Yes.
Space TV asks, do you have a preference for colonizing space? Like, should we focus on colonizing the moon, Mars, or create space-based colonies instead, or just do everything?
I'm in favor of all the things. If I had to pick, I think I'm with you, Fraser, about asteroids, habitats.
Gravity wells are for suckers.
For habitats for humanity.
There you go. Yeah. I think the more I think about it, the more I'm just a gigantic fan of the Earth.
Earth is pretty awesome.
Right? Like, where else will you
Earth
get
is pretty great.
Oceans and dolphins and koala bears and
we have forests,
redwood forests, and air that you can breathe when you just walk outside your house, and all of these kinds of things, right? And And so then the question is, why do you want to go
Parmesan?
You have Parmesan, right?
I mean, come on.
Cows that can make Parmesan. So the question is, like, why do you want something different? What's that about, right? And so I think if, like, space is this great place where we can utilize all of its resources to make Earth even better and less gross. And I think we should. And I think that whatever we figure out is going to do the trick. So Earth is the best. The universe, if it is empty and as dead as we think, or it appears to be so far, then we can just fill the whole place up with our garbage and harvest all of its resources and make Earth even better. Like,
even better.
Super cows.
Screw you, Mars.
Mega cheese, right?
Mega cheese.
Like, let's just make Earth even better.
Yes.
So I think that's.
But what would low gravity cheese taste like?
Sure. By all means, take your cows to space, make them figure out some kind of low gravity environment and make cheese in the perfect environment, and then bring that cheese back home to Earth where you can enjoy it in the way a Type 3 civilization intended it.
Done.
Adam Sanders says, who was it that pointed out that why would we colonize Mars if nobody's colonizing Antarctica? Which is, I think, a great point, right? Like, I mentioned on my last QA was, would you, if you are up for the adventure of going to Mars, try just living the adventure of growing all your own food for a whole year, right?
Or living in a cave.
Well, grow you all your own food and live in a cave, whatever, right? Like I'm not
and drink your own urine.
I'm not saying be extreme. Like, just take something that just demonstrates how, like, put yourself in some really serious constraints to your existence, and then just see whether a year later you're like, that was a lot of fun, I want more of that. Then get your ass to Mars. We need you on Mars. But if you walk out the other side of it and you go, that wasn't fun, I miss dolphins and cheese, then stay on Earth with us.
Come on. We'll share.
Tim Bargan asks, this is a good one, is it possible for fusion to occur in a black hole's accretion disk?
No.
What is, like, all of the light that's coming out of a black hole, supermassive black hole's accretion disk?
Right. So tons of, like, in fact, the brightest things in the universe are the accretion disks around supermassive black holes. And they're bright because it's a lot of stuff crammed into a very tiny volume with a lot of energy, and it gets really hot. Not necessarily very dense, where you need hot and dense to ignite fusion in the core of a star, just really hot.
So but can't hot replace dense when you're looking to do fusion? I have heard, and I could be wrong, that in fact you do get the conditions of fusion in the accretion disk of a supermassive black hole. But
sure, whatever.
I'm in the same way that in the early universe you had, the entire universe was a star, which was how we got helium and lithium. And
well,
so another form of nucleosynthesis.
I wouldn't call it the whole entire universe was a star. Maybe I would. Okay, I'll allow it. I'll allow it this time, Mr. Cain.
Let me just search up nucleosynthesis black hole accretion disk, and then we'll find out. Yes.
Maybe.
Products expelled by winds driven by super Eddington accretion and enrich the interstellar medium. All right, let's move on. N-Steam asks, do stars fuse heavier elements as soon as it is possible, or do they wait until no lighter elements are available before doing it?
Yeah, so stars do follow a staged approach here, where they'll first fuse hydrogen. Then when that gets removed from the core, then they fuse that into helium, and then to carbon and oxygen, and silicon, magnesium, iron, nickel. And they'll do it over the course of their lives. And towards the later stages of the star, you have layers of fusion where there's at the very outermost layer, there's still hydrogen fusion going on, and underneath it, helium, and on and on and on, all the way down to the iron core. So it always starts with hydrogen into helium.
And they're all happening like at the same time? Like you got the hydrogen in the core with the helium around that, and that's happening at the same time? Like, can you get, because helium is building up inside the core of the star, but you just don't have the conditions for the helium to fuse until you get that shell of the significant density and temperature, right?
Right, exactly. So there'll be hydrogen burning in the core, then a bunch of helium settles into the core, and that pushes the hydrogen burning out into a shell around it. And then once that core reaches a new critical temperature and density threshold, you get helium fusion in the core, and then that leaves behind carbon and oxygen in the core, and then everything gets pushed out, and then it slowly builds up this onion layer.
Space TV wants to know, what does Dr. Sutter personally think is the most interesting mystery in the universe?
The very fact that we can understand the universe at all. Whoa.
Let's talk about your book.
Why not?
What's it about? Now, I
My
have
book
read
is
it.
About.
So,
you have?
huh? Yeah. Just like you read it? I'm sure you read my book. So.
Oh, cover to cover.
Yeah. But yeah, no, I really enjoyed it. Here's my review. It's like Matt Sutter is talking to you with words as opposed to his talking sound.
You read it in my voice.
Yeah, absolutely. So you like, it's possible that people may know that you're a fairly sarcastic guy, and the sarcasm comes through strong. The puns are forceful,
hot and heavy.
Yeah,
forceful puns.
I caught
that. Now that is the blurb. The puns are forceful.
You even did an unintentional.
I did one unintentional pun that my editor caught that I did not intend to make, and it was awesome. And my editor was like, "Aha, that was pretty fun." I'm like, "Oh no, that was an actual pun that I missed, and I did accidentally, so I had to call it out in the book."
But also explain that you hadn't noticed it the first time around, which I thought was fun. Mm-hmm. But yeah, so what is the story that you're trying to tell here?
I'm trying to tell two stories here. One is the history of our universe. How did we get here on planet Earth 13.8 billion years after the Big Bang? And then also, how did we get here in the 21st century knowing that story? And to me, these are parallel stories. These are interwoven and interleaved stories about passion and discovery and really awesome physics.
Was, in going through the process of telling these stories, did you learn some things that maybe some pieces of the history or some of the personalities of the people involved? Because the personalities of the various players play fairly. You seem to really enjoy the behaviors of your fellow scientists and the scientific forefathers. How did that go?
Oh, that was so much fun to dig into the history and actually read their papers, like Edwin Hubble's paper about the discovery of the distance to the Andromeda Nebula, the discovery of the expansion of the universe. He was a really snappy writer. His papers are pretty short and to the point and really punchy and really fun to read. And that was really awesome. Or you read, especially in the 19th century, journal articles and personal diaries of people trying to understand this, and you can just see their confusion, oozing out of their writing of just what the heck is going on. What is a spectrum? Why do some elements have a spectrum? What is this even? I don't know. And it was just a joy to see these individual personalities come out where they're at the core, they're always the same. They're really passionate. They're really curious. They're really driven. They're really hardworking, but they add their own flavor and nuance to it that just makes it so much fun.
So which of them would you love to hang out with? If you could like just spend time just like seeing the way they thought and even seeing the way they interacted with other people, which of the scientists of yore would you love to just like have as a, to have a cheese party with?
So I'm gonna pick two. One, I want to sit down with Johannes Kepler, just so he can rant like a madman that he was.
Yeah,
and I can enjoy.
Sound like a long-term friendship. That sounds like just being
no. It's just one night. This is just one
end
night.
of a bullhorn.
Yeah. No, we're not going out to the movies or anything. I'm just gonna eat dinner and listen and be entertained. It's like dinner theater.
Yeah.
Listening to Kepler. And then someone who didn't appear in the book because the story didn't quite align was Michael Faraday. Michael Faraday, early pioneer in understanding the nature of electricity and magnetism. He held annual Christmas lectures and public demonstrations. He had a flair for science communication before science communication was really a thing. And by all accounts, he was like a really, really cool guy. So I had to hang out with Michael Faraday.
And who would you keep away from as much as possible?
Everybody else.
I see. So, I really got the impression that there was like, I would, you talked about Fred Hoyle.
Mm-hmm. Well, Fred Hoyle is like a delight.
But also like derisively coming up with the term Big Bang. Just like, like it was some big bang. We treat it in some, English accent on the BBC. But
it's like, I mean, there are all these wonderful cast of characters. Honestly, I'd have dinner with any of them because they're brilliant minds. They're really creative. Even if I disagree with them, they'd be fun for at least a night.
Yeah. I see you, Rami, Ahmed. Sorry, just lots of questions coming. For a lot of people are like, why isn't Fraser? Because there's about a 10-to-1, maybe a 20-to-1 factor of the questions that are coming at me matched up with how many we have time to get through. So now, you know how this works, right? You finish your book, you're out on the book tour, you're doing the publicity. The next question is, are you going to do another one? Because that's really like, that's writing a book is brutal, and it is an experience that you don't want to necessarily repeat.
And then you do it again.
And then you do it again. So, yeah. So where are you now?
I am planning. I do have a couple active pitches out there that my agent is shopping around. My current publisher is right of first refusal, so they're considering it. If they give a go, then it's right on to book number 2 with Prometheus. If they pass, then it gets shopped around to the wider publishing industry. So we'll see. It's just a matter of time. I'm probably going to write another book.
You should write a letter to yourself, in the midst of writing that book.
Future
Paul, who's just
don't do this.
Exactly. It is.
I'll say, I got a book deal. It says open in case of book deal.
In case of book deal. Yeah. Yeah. Oh, right.
The book deal.
Yeah. It's work and stress. All right. About to wrap things up. We've already shamelessly self-promoted your book. Please tell me some other interesting things that you're working on that maybe, and I also mentioned your newest article. So I guess we're done, but tell people some interesting things that you're working on that maybe they should come and check out.
Well, they should definitely check out Astro Tours. We are doing our All-Stars party in Joshua Tree National Park, which is now open. Thankfully.
Yes. So well, for now, we don't know what the
for now. Hey. It's just open. We're just gonna celebrate Joshua that. We're not gonna think about anything else.
Yeah.
That's at the end of June. Go to astrotours.co and look for the All-Stars party, and it's gonna be tons of fun.
Yeah. And you, me, Pamela, John Michael Gautier, Skylius, a bunch of fantastic telescopes, incredibly dark skies.
What's not to love?
There you go. All right, Rami, I'll give you your question here. You said, is it proven to be impossible to design an experiment to determine if we live in a simulation? Yes.
We'll never know if we live in a simulation.
It is impossible to know if we live.
And it doesn't matter. Yeah. It doesn't matter.
Because if we are in a simulation, we don't know if actual base reality has anything to do with our current reality. So even if we think we found evidence, it could just be the programmer's
simulation.
Yeah. So we could
also be in the dream of an angel.
Right. So we can never know. And so you just have to live your life as if you live in a non-simulation that is not predetermined.
Yeah.
So, all right. Well, hey, thanks everybody for joining us for the show today. Very fun. Paul, as always, pleasure hanging out, and we'll see you on Wednesday for the Weekly Space Hangout and whatever news has bubbled up by then. And of course, go check out his website, PM Sutter. I'll put a link to his YouTube here in the show notes and the little cardy things. And congrats on the book. I really enjoyed it, and I look forward to the next one.
All right. You can. I don't. Take it easy.
All right. Thanks a lot.
Bye.